Simulation modeling to analyze the effectiveness of risk mitigation strategies on an apparel company operations. First, the basic processes of the apparel company were modeled. These has create modules, decide, assign, dispose and various and graphs and variables. Let's run this setup. Materials arrive at certain rate and then the quality of garments are checked. Then the materials proceed to cutting section. Graphs show the details. If the material needs printing, they will move to printing section. If not, they will proceed to sewing directly. Average number in queue is displayed and the final garment is checked for quality. Quality garments proceed to washing. Defect garments go to repairing section. This is the washing process. You can see the queues building up. In finishing section, the animation shows the employees are busy. Finished garments are again checked for quality and then they are moved to packing division. Here, batches are maintained. In the model, you can see the red balls moving to repairing section. This is the packing place. The animation shows their system is busy. Graph clearly shows the number in the packing queue. Garments are finally packed and moved out of the system. You can see the final reports. These are the waiting times and average number waiting in the queues, and this is the resource usage report. You can see that also. Simulation of a quality failure. The model can be simulated to see the impact when the quality garments percentage suddenly drops to 25%. Let's run the model. The materials coming out of sewing are going through repairing section more frequently. You can see the number of defect garments is higher than the quality garments, and the number of passes per entity shows the number of passes a garment moved through the repairing section. You can see queues building up. Not the number of passes per entity, it is increasing always. Even it's going to 2 and even more than 2. Here you can see the number of defect garments is more. Let's speed up the model. You can see how the number of passes per entity change. It even goes up to 3 iterations. When the one entity goes through repairing repeatedly, it will further improve the chance of that entity being bad. Let's see results. Average usage of resources is like this. For risk mitigation part, we have used risk acceptance and limitation. Here we are controlling the number of bad parts. If the number of passes per a garment is less than 2, it will be directed to repairing. If not, garment will be sold at scrap. Let's run the model. Note that the number of passes per entity does not go over 1. That is because of that condition. Now there are more quality garments than before. Now the processes will be at high efficiency. Here you can see the average usage has increased. So we can say that the mitigation strategy is effective. Simulation of a machine breakdown. Here the packing process has only one machine, and we will see what happens if that machine is broken down. See the queues building up, and because this is a bottleneck process, after packing, the processes that are there cannot be performed. They are idling. And you can see the huge queues there. As the risk mitigation strategy, risk avoidance is used. For packing process, here we have used a set of resources, that is a set of machines. You can see the spare machine can be used in case of a machine breakdown. Then the number in the queue reduces than before, and also other processes can be performed without idling. This proves the effectiveness of the strategy. This could even be used for calculations if needed. Simulation of a late delivery. Here, late delivery of materials by suppliers is simulated by reducing the number of materials that are arriving. Let's run the model. See that the number of materials are very low. There are less number of work for people in processes, no queues. In finishing, laborers are idling. The average resource usage has to be low because there are idle workers and idle machines. The risk from the late deliveries can be mitigated by adhering to multiple sourcing policy rather than using the single sourcing policy. So we are now getting materials from another supplier. So in a late delivery, we can still have materials for processes. So as you can see, there are materials coming from supplier B also. The average usage of resources has to be high of uncertain demand. This can be simulated by increasing the material arrival rate. The assumption here is that if the demand increases, company may ask for more material from suppliers. So material arrival rate increases. You can see how the queues are building up. Goods move out is less. Instead, there are more work in progress. Average number of garments out from the system is 5. Mitigation strategy. The company can use a buffer stocks to satisfy the high demand. We'll run the model to see the effectiveness. See, the number of goods move out is more than before because the package is packed with 2 garments. The total number of garments is 28. That's so overall this model can be used to see the effectiveness of mitigation strategies on risks. Thank you for watching.